Hello students, this is Kumar Physics. Today I am going to discuss about semiconductor device. Semiconductor devices. Okay. So to describe about the semiconductor device and electronics. Okay. Now please subscribe my channel Sri Sai Physics for Mains and NEET, and also share for first year and second year students who are going to read. Okay. So see the topic, semiconductor device. In nature, how many substances we observe? There are, for example, now I am considering a solid. This solid is either in the form of a crystal form, or in powder form. Solids are divided into two types. The first one is the crystal form, second one is powder form. In crystal form, all the atoms are arranged in a regular order. All the atoms are arranged in the regular order. In powder form, they are not in a regular order. Okay. Now, again these solids, based on the electrical properties like temperature, conductivity, like that, pressure, they are divided into three categories: conductors, insulators, semiconductor device. Semiconductors. Now, this conductor, what is meant by a conductor? The conductor is a device which conducts electricity very fastly. Yes or not? So here, in the case of insulator, there is no passage of current or electricity. In the semiconductors, the properties which lies between the conductors and insulators is called semiconductor device. The properties which lies between the conductors and insulators is called semiconductor device. So this semiconductor device is of two types. The first one is called intrinsic. Semiconductor. And second one is called extrinsic semiconductor. Okay. So again, what is meant by intrinsic semiconductor? That means this intrinsic semiconductor is said to be having 4 valency electrons in the outermost orbit. That 4 valency electrons is nothing but tetravalent. So for example, germanium, silicon will have 4 outermost electrons present in the orbit. So now what is extrinsic? This intrinsic is also called pure. So the semiconductors which are in the pure form is called what? intrinsic semiconductor. Okay. Now, what is doping? I want to convert the intrinsic semiconductor into extrinsic semiconductor with the help of doping. So, this doping means adding of impurity, to intrinsic semiconductor. Adding of impurity to intrinsic semiconductor will gives what? Extrinsic semiconductor. So this extrinsic semiconductor is again two types. This is P-type semiconductor and N-type semiconductor. P-type semiconductor and N-type semiconductor. So now check how to get P-type semiconductor. To get the P-type semiconductor, what we should do? So for that, let us consider germanium. This germanium will have 4 valency electrons in the outermost orbit. 4 valency electrons in the outermost orbit. Now take aluminum. So this aluminum will have the value 13. So whose configuration contains as 1s2, 2s2, 2p6. So up to this all the electrons are filled. So hence the remaining 3 is present, valency electrons in the outermost orbit. So now I am taking this as aluminum. So what happens? There is a covalent bond formation. Covalent bond formation. How many covalent bonds formed? 3 covalent bonds formed initially. Then what happens? To get the 4th covalent bond, the electron should be come to here from lowermost level to uppermost level. That means there is a vacancy. Present. That vacancy is said to be hole. This is not present actually. So for that there are 2 types of bands. One is called valency band and other one is called conduction band. One is called valency band and other one is called conduction band. So that the topmost filled level with electrons is called valency band. The next higher unfilled level is called conduction band. Okay, the topmost filled level is called valency band. The next higher unfilled band is called conduction band. Okay. So between this valency band and conduction band, there exists a gap. What I told, valency band is filled with electrons. The next higher unfilled band is called conduction band. Then what happens when the energy is given here? Then due to this energy, this electron will be jumped to higher level. Then what happens here? A vacancy is created. This vacancy is called what? Hole. This vacancy is called hole, and this energy gap between the valency band and conduction band is called forbidden energy gap. Forbidden energy gap. Okay. Now here what happens? These holes, when the doping is done with the aluminum, there exist 3 covalent bonds. In order to form 4 covalent bonds, one electron jump from the valency band to conduction band. So holes are present mainly. Then we can say the majority charge carriers. The majority charge carriers are holes in the p-type semiconductor, and the electrons are said to be minority charge carriers. Minority charge carriers. Okay. So this forbidden energy gap is represented by Eg. Eg. This forbidden energy gap in the case of conductors, there is no forbidden energy gap between the valency band and the conduction band. That means both are overlapped together. That means the forbidden energy gap is equal to 0 electron volt in the case of conductors. In the case of insulators, there exists a forbidden energy gap more than 3 eV. So the forbidden energy gap in the case of insulators is more than 3 eV. Next, in the case of semiconductors, the forbidden energy gap is less than 3 eV, lies between 0 and 3 eV. That is about the energy gap. Okay. So for germanium and silicon, the value is 0.7 eV and 1.1 eV. For germanium, the energy gap is 0.7 eV and 1.1 eV. Okay, this is about the forbidden energy gap and valency band and conduction band. Now here I explain what p-type semiconductor. This is the p-type semiconductor. To get the p-type semiconductor, the doping should be what? This is a trivalent impurity. Trivalent impurity. So here this impurity is also called acceptor impurity. Okay, there are two types of impurities. One is donor and second one is acceptor. So this is the acceptor impurity. That means here this is accepting an electron to get the formation of a covalent bond. So that's why this impurity is said to be acceptor impurity. To remember this p-type as positive, holes are having positive charge carriers, so they have positive charge. Okay, now what is to get the how to form an n-type semiconductor? How to form an n-type semiconductor means we have to add pentavalent impurity. Pentavalent impurity, so that this pentavalent impurity will have 5 valency electrons. 5 valency electrons. These 5 valency electrons, for example, I am taking the phosphorus. In this phosphorus, the electronic configuration which contains 5 valency electrons in the outermost orbit, so that this phosphorus is added with aluminum, with germanium or silicon. Then you can draw the diagram like this. Again, this is the germanium which contains 4 valency electrons. Now for this phosphorus, how much free electrons, 4 valency electrons are present. So this, in addition to 4, there exists another one. Totally 5 valency electrons are present, but for the formation of 4 covalent bonds, 4 valency electrons are closed and the remaining 1 electron is present. Remaining electron is present. So that means for every atom of phosphorus, the electrons will be exist more. So the electrons are the majority charge carriers. Majority charge carriers in the n-type semiconductor. Electrons means negative or not. Holes are the minority charge carriers. holes are the minority charge carriers. Okay, so add to this is the how p type and n type semiconductors are formed. Okay, so for the next class we will see how p-n junction will be formed, and based on that we can explain the diode depletion region. So like that you will explain. Okay, thank you for watching. Please subscribe my channel Sri Sai Physics for Mains and NEET. Okay, thank you and share it.